Hi, welcome for the second episode of 5 Ways of 555. This time we are going to discuss about the monostable mode. 555 in monostable mode. In monostable mode, our pin number 7 and 6 is connected together. So that's our discharge pin and the threshold pin. And we are supposed to give a low going trigger to our pin number 2. And when that happens, our output would go high for a time that governed by the RC time constant of that R and C. So that is 1.1 time R times C. So in my case I got 100K and 47 microfarad. So if you plug the numbers in, so this is my trick. When it always comes to RC time constant, I put R in mega ohms and C in microfarads. So that's easier to calculate. So in that case I'll get 5.17 seconds time. So our output pulse would be high for 5.17 seconds, and then it goes back to low if you don't have anything at the trigger pin number 2. So if you look at the block diagram and see how it works. So as I mentioned, 6 and 7 together, connected together. So we are dealing with this 2 times VCC divided by 3 voltage threshold. So if we give a trigger a voltage that is less than VCC divided by 3, so that will set the flip-flop. So that's the set the flip-flop. That means you have one output here and it will be 0 output over there. So as soon as you get a 0, the transistor is off. That means our discharge pin number 7 is no longer connected to the ground. So that means our capacitor can get charged. So 0 here, and that's our high output there. So the capacitor is going to charge. It's going to keep charging, and as soon as it hit our voltage threshold, which is 2 times VCC by 3, the flip-flop going to get reset, and this output will be 1 here, and that means our transistor will turn on and discharge will be connected to ground, and the capacitor will discharge. So 1 here, and then 0. That's our 0 output at the end from the output. So I got this little circuit to demonstrate it. To give that low going trigger, I got a reed switch. So if I bring a magnet closer to the reed switch, that it will connect that pin to the ground, so that will give the low input that the IC needs to trigger itself, and it's going to keep our LED bar from the last experiment on for 5.17 seconds. So that's our circuit. As you can see, that's my 100K pull-up resistor there, and there's the reed switch, which is connected to pin number 2, our trigger, and I got the capacitor and the 100K resistor. So the junction connects to pin number 7, and 7 and 6 connected together. I got the capacitor connected to pin number 6, and see what happened when I bring a magnet over to the reed switch. So at the moment the voltage is 0. So I got 2 cursors, that the S is 0 volts, that's that, and E is 8 volts. So in my case, because I got 12 volt power supply, so that is 2 times 12 divided by 3, that's 8 volts. So that's what that E cursor is. So let me bring the magnet and see what happens. The output goes high, so LED bar get turned on, and see it kept on charging till our threshold voltage, and as soon as it gets to the threshold voltage, switched off. We try that again. There you go. Goes off. So that's a simple monostable mode using the 555 time IC. I thought we could improve our circuit. So I did bit modification here. Instead of that 100k, I put a 1 meg there, and in here for pin number 4, that's our reset pin. It was connected to the positive rail before. Now I got a 1k resistor connecting to the positive rail and got a switch that goes from 4 to the negative rail. So what that does is, when the button is not pressed, it is connected to the positive rail. So it is enabled, so it would work as before. But if I press the button, so that resets the 555. So the output would immediately go to low. It'll turn the 555 off. So it's like a little practical application. It's so now because of the 1 meg, our time is a bit bigger, so it won't be a much. That'll be 51.7 seconds. That's a reasonably long time. So if that is too long, if the user want to turn the light off, the light LED bar off, can press the switch. Okay, let's bring the magnet. There you go. The light bar's on, but it's going to keep on for a decent amount of time. So if I need to turn off, I'll press that button. It immediately goes off. If you like this video, please smash that like button and don't forget to share and subscribe. See you next time.